All right, today we're going to be talking about section 9.4. We're going to be talking about perimeter, area, and circumference. So we're going to look at perimeter of polygons, area of polygons, circumference of a circle, and area of a circle. So when we're talking about perimeter of a shape or of a polygon, we're talking about adding the measures of the line segments that form the sides. So we're talking about adding up the outside of the shape, the sides of the shape. And this is always considered a linear unit, which means it's going to be inches or centimeters or feet, not square inches or square centimeters, which we'll talk about also. So a few of these I'm going to give you formulas for, but one of the things you've really got to understand is that the perimeter is just simply adding up the outside of the shape. So if I wanted to find the perimeter of this triangle, I want to add the value of side A plus the value of side B plus the value of side C to find the perimeter. If it were a four-sided figure, you'd want to add all four sides together. And here we have a rectangle, and so to find the perimeter of the rectangle, we know that with the rectangle the opposite sides are the same, so this has a value of L also, and this has a value of W. So if I wanted to find the perimeter of this shape, I would say L plus W plus L plus W. And so that's rewritten, if we combine like terms, as 2L plus 2W. And if we factor out that common 2, that's where they come up with the formula 2 parentheses L plus W. So either one of these formulas that you see here can be used to calculate the perimeter of a rectangle. The perimeter of a square, remember that all the sides of a square are the same. So all the sides in this example are S. So if I wanted to find the the perimeter of the sides of the square, I would say S plus S plus S plus S, which will abbreviate to 4S. When we're talking about the area of a polygon, the area of a polygon is always measured in square units. And we're talking about how much surface is covered by this shape when we're talking about the area of a polygon. So here we have a rectangle again, and the area of a rectangle is the length times the width. So when you see over here LW, that's the same thing as saying length times width. So I want you to find the perimeter of this rectangle and the area of this rectangle. So remember, the formula for perimeter is 2L plus 2W. So we're going to call the 15 the L and the 7 is the W. And it honestly doesn't matter which one you call the length and the width. Just label them so you don't forget. And substitute that information in. So 2 times 15 plus 2 times 7 gives you 30 plus 14 is 54 feet. Oh, excuse me, 44 feet. Just added wrong. Okay, if I want to find the area of the same rectangle, it's length times width. So it's going to be 15 times 7, and 15 times 7 is 105. And we write this as feet squared or square feet. You can say it either way. So when we talked earlier about having linear units versus square units, the number of feet in the perimeter is 44 feet, and we just simply wrote feet, but the area is 105 feet squared, so it's a square unit. All right, now we want to find the area of a square. Area of a square is given by the formula. If we think about it as a rectangle, it's just length times width, but the length and the width are the same. So if we think about it that way, length times width, but the length and the width are both s, so it's s times s, and that's how this s squared comes about. Okay, the area of a parallelogram. A parallelogram is a shape, remember, that we talked about, that has four sides. The opposite sides are parallel, but we don't have a length and a width because the side that is sloped here is not considered the length of the parallelogram. So we talk about something called a base and a height. And the base is the two sides that the height is perpendicular to. Notice the height is always perpendicular. Here we go again. Here we have the height is perpendicular to the base. So that's how you can establish which one is the base and which one is the height. A trapezoid. A trapezoid is a shape with two sets of parallel sides and two sets of non-parallel sides. And again, we have a height with that trapezoid, and we have two bases. It doesn't matter which one's big B and which one's little b. And you've got your formula 1/2 height times base 1 plus base 2. So let's look at an example of that. So in this case, we're going to call the 13 big B, and we're going to call the 7 little b, and the 5 is our height. So our formula is 1/2 times the height plus big B plus little b. So 1/2 times the height, which is 5, big B, which is 13, plus little b, which is 7. Remember, order of operations tells us to do the parentheses first. So we're going to do 1/2 times 15 plus 20, times 20. And following our order of operations, we're going to end up with, oops, sorry, this is 1/2 of 5. Okay, so 1/2 of 5 is 2.5 times the 20, ends up with 50. And since we're talking about area, it's going to be centimeters squared. All right, so we have the area of a triangle. Formula for area of a triangle is 1/2 height times base, or base times height. The base, again, the height is always perpendicular to the base, so this is our height, and the base is here at the bottom. So here we're going to combine some things together. Now what I want you to do is find the area of the shaded region in this shape. So there are a couple of different ways to do it, but one of the ways I want to show you is that basically you're looking at this as two shapes. You have a square, and the square has sides that are 4 by 4. And then you have a triangle, and the base of the triangle is 4, and the height of the triangle is also 4. Now we know that because here we have this 4 that is representing this side of the square. If I take that 4 and I slide it over here, it's also right here. So right here you'll notice that this piece right here is also 4, just like this piece over here is also 4. So the height of the triangle represents that perpendicular distance. So the height is 4, and the base is 4 because opposite sides of a square or opposite sides are congruent. So now what we're going to do is we're going to do two things. We're going to find the area of the square, and then we're going to find the area of the triangle, and then we're going to take the area of the square and the area of the triangle, and we're going to subtract them. So let's go through that. The area of the square is going to be 4 squared, which is 16. The area of the triangle is 1/2, 4 times 4, which is going to be 1/2 of 4, which is 2. 2 times 4 is 8. So then the area of the shaded part of the figure is 16 minus 8, which is 8 inches squared. And that's what I'm telling you to do in these directions. If you'll notice here, we said find the area of the square, which is s squared. The area of the triangle is 1/2 base times height. We found the area of the square, the area of the triangle, and then we subtracted those two, and we got 8 as the area of the shaded part. There are other ways to do that problem, but that's one possibility, and I want to show you another example in a minute that uses that same process. Okay, so when we're talking about circles, we don't talk about the perimeter of the circle, we talk about the circumference of the circle. But the circumference, again, is still just the distance around the circle. So there are two different formulas that we can use for the circumference of a circle. The first one is not as common. It's pi times d, where d is the diameter. And the second formula is 2 times pi times r. And remember that the diameter is just the same thing as 2 radii put together. So the two formulas are equivalent to each other, and it just depends on which one you're more comfortable with. The formula for area of a circle is pi times r squared. And in both of these cases, I did forget to mention that the value of pi, and this is usually told to you on formulas, on problems, is usually represented as 3.14. So whenever you're talking about a problem and it's talking about pi, you will typically use the number 3.14 in your calculations. So here we have an example. Find the area and the circumference of a circle with a radius that is 6 inches long, and use 3.14 as an approximation for pi. So again, usually you'll be given that information. So circumference is 2 times pi times r. So we're going to substitute what we know into this problem. Oops. And the radius is 6. We're going to go through and do our calculations, and we end up with 12 pi, which is equivalent to 37.68 inches. And when we do our area formula, we have area equals pi r squared. So pi is 3.14 again. The radius is still 6. So we're going to end up with 36 pi, which is equivalent to 113.04 inches squared. So that's our circumference and our area of the circle. Now, depending on the problem, you have to be careful on the wording of the problem. Occasionally the problem will say enter the answer as pi, and so you'll notice that I wrote my answer two different ways. I wrote 12 pi, and then I wrote 37.6. The first answer is in terms of pi, and the second answer is actually multiplying pi into the problem. So just be careful about the wording. If you see that phrase, make sure you just leave the pi in your answer. So here's another example, and this is where you have the multiple parts. Find the area of the shaded region. Okay, so what we have here is we have two shapes. We have a square and we have a circle. Okay, so the area for a square is s squared, and the area of a circle is pi r squared. So in this case, you'll notice that the 10 that we have here is our radius. And if I extend the 10 out to the other side, I also have 10 on the other side. So the diameter of the circle is 20. And if you think about that again, if I think in terms of dropping that diameter, you'll notice that the length of the sides of the square are also going to be 20. So when we're finding the area of the square, it's going to be 20 squared. And when we're finding the area of the circle, it's pi times 10 squared. Because remember, our radius is 10. And so if we do our calculations here, again, what we're going to do is we're going to find the area of the square and the area of the circle and subtract them. So the area of the square minus the area of the circle ends up to be approximately 86. And I didn't have units on there. So if you wanted to write units, you could say units squared, just to put a U for the units. And so that would be the area of the shaded region. All right, I hope this has helped. Keep in touch with me. Let me know how things are going. We will be having a test in the next couple weeks, so watch out for your time. Hope you have a great week.